All right, so welcome both of you for our first class, that is Introduction to the Deep Learning. Before going to this deep learning lecture series, let us first understand what is the basic of this all kind of stuff and why we are in a demand or why we are in this process of doing such activity. Okay, so as we know that artificial intelligence, AI, that it keeps very much importance. Everything everywhere is now going to be under the automation. Okay, because we developed machines, humans developed the machines because to solve the problems. Okay, so machine are having good computational capabilities. Okay, so we have developed the computers, and from 1950s until now we have done lot of changes. There are a wide have scope, or I would say that whether if we deal with the hardware or software, both of them, there has been a lot of changes has been done. Okay, and now these all machines and systems are now very much capable enough to solve our problems, whether because we have developed too much algorithm techniques, they are being software or applications, whatever we can say. uh, we are just trying to get much more real world applications, real world problems to get solved with them. Okay, so how this is going to be possible, what made these things to be possible? It's all about the first step is a learning. Okay, so before going to the deep learning, we should know what a learning is. Okay, so learning, just like you do, I also do learning process. So learning is basically, it's a process that leads to change. Okay, which occurs as a result of experience and increases the potential for improved performance in the future learning ahead. So I want to bring a change. Okay, as a result of my experiences. Okay, whatever I'm doing something, for example, I'm doing something, I got stuck somewhere. Okay, then I search for that particular problem, I found some result, or whether it I didn't found anything, then I did ask to someone, okay, I got stuck somewhere and please kindly guide me, help me. So he or she gave me some solution, I learned this thing. Okay, that means I have some memory related to it, I applied that particular solution over to problem, I get the results. Okay, so learning is a continuous process. Okay, it's not a one time, it's a continuous process that brings a change in you. Okay, when you go through certain problem statement, or when you proceed ahead to do some task or work, obviously you get some experience related to it. Okay, so learning is basically an experience, it's to gather an experience. Okay, whatever it may be. Okay, and just there is a improvement, just keep on having an experience, keep on updating yourself and bring a change in yourself, and that is called as an performance. Okay, improved performance. Okay, now the next thing is here, intelligence. Okay, how you define intelligence? See, the capacity of abstraction, that means acquiring something, acquiring data, acquiring knowledge, acquiring information from any of the sources. That is abstraction. Abstract, and just setting up, or just acquiring, relevant information. Okay, essential part. So capacity of extraction, logic. If you have a logic, that means if you can relate the things better way. Okay, if you can apply some technique, so this is called as logic building. So logic understanding, if you have a good understanding of the concepts, so obviously self awareness, if you are aware that if I am going to do this thing, this is going to be correct, if I am going to do this, this is not going to be correct. So this is something awareness. Okay, so learning, emotional knowledge, reasoning, that is the ability to reason. Okay, why I should do this and why shouldn't I do this, there is some algorithm behind it, reasoning, technique, planning, creativity, critical thinking, problem solving skills. If you are being able to have all these abilities, that means this shows that how intelligent you are. Okay, so in this world there are different people. And everyone is having a brain, obviously we all are having brain, but we say that okay, this one is much more intelligent, this one is less intelligent. So how we measure them? On the basis of success. Okay, this person is very much successful, okay, and very very active, or and he or she got a very good knowledge. So how they got the knowledge? Because they have a capability to logic, to give a logic. They have a reasoning, they can give the reasonings. Okay, they are very much aware. They have they have creativity, that means some new idea to apply over the problem statements to get the results. Okay, and they are having a good problem solving skills, so they do solve the things in a very quicker time. So we say okay, they are intelligent people. So this is what an intelligence is. Okay, so the ability to perceive the information and to retain the knowledge. Okay, just get the information and retain the knowledge to be applied towards adaptive behaviors with context of the environment is said to be an intelligence. Okay, so you should have all these things in your personality. Okay, and then if you can get the information and acquire the knowledge from it, and accordingly if you perform well in the environment, or I would say in the surrounding or in the system whatsoever, then you will be called as an intelligent. Okay, so first the learning comes. Okay, I'm just keep on learning the things, and if I'm very much intelligent enough, definitely I can turn up the things. Okay, so we humans basically, because there was not machine priorly, machine came later, and we are the people who developed the machine. We are the people who developed the computer. So obviously, we are much more intelligent than the machines. Okay, so we kept on learning. We are intelligent. We developed the machines, and now what we want to make is to make a machine intelligent. Okay, that means we just want a machine to be compatible like us. Okay, so then there comes a concept called as AI, or artificial intelligence. Okay, which means that I want to simulate human intelligence in the machines. So that means what kind of intelligence I am having, that same intelligent machine should also have. Okay, so how I can make a machine intelligent? Ultimately, if I define AI, so AI is something just making machine intelligent. That is artificial. We people are real, but machine is not real. Okay, so making machine intelligent is called as AI. That is my simple definition. Okay, so we want to simulate the human intelligence into the machines, and we want machine to solve the problems. Basically our main goal was that only, to make the machine solve the problem. So here also in AI also we want the same thing. Okay, so ultimately I want to feed the machine with some intelligence, some creativity, some reasoning, some knowledge, some awareness, logic. I want to feed all these things into machine, so machine will become intelligent, and accordingly the machine will, what, after learning and getting the intelligence, machine will solve the problems. Okay, machine will get in power to think, what to do, decision making. The machine will get a capability. So this is AI. And the ideal characteristics of AI is to rationalize and take actions. Basically that is what I told, that the goal is to just make the machine intelligent and let the machine to do the task, and take the actions, what to be done and what not to be done. Now, as we know that machine learning is a subset of artificial intelligence, machine learning comes under AI only. Okay, so it refers to the concept that computer programs can automatically learn and adapt due to new data. Okay, without any human intervention. So what we do in our projects also, machine learning projects also, we have a data set. Okay, we feed the data set into the model. Okay, and train our machine learning model. Okay, that if you are having these much parameters, okay, so get trained yourself by this data. When you get another kind of problem similar to that, now you are having an better knowledge of it. So this is next time you are able to give the answers to them. Okay, so here what we do in ML is we are making our computer programs automatically learn from and adapt to the new data. Okay, and ultimately here we are training our models accordingly with this data, and whenever a new problem come according to the data which we have trained, so obviously it's giving you the results. If you talk about deep learning, what is this deep learning? See, deep learning is a subset of machine learning. So machine learning is a subset of AI, and deep learning is a subset of machine learning. Deep learning enables automatic learning through the absorption of huge amount of unstructured data. Unstructured data, huge amount of unstructured data. Here I haven't talked about a huge amount of data. I haven't talked about the big data. However, if you talk about the deep learning, the concept here relies on huge amount of data. Okay, that means you're not having only 10 thousands of lines or rows for your data set. No, here you may have lakh of rows in your data set, and your data will not be specific to some of these also. It can have images also. Okay, it can have videos also. So I need to train my model with the help of images, with the help of videos. So it is not been your traditional machine learning algorithm is not much capable enough to work upon these kind of data, huge amount of data, because your model will gonna fail on this kind of stuff. So because of that reason, there comes a concept of your deep learning. However, let us first put some light on machine learning. Let's have some discussion related to it. Machine learning, it learns from the historical data, as I told, then it builds the prediction models whenever it receives the new amount of data and perform the predictions over it. Okay, and the accuracy of the output depends upon the amount of data. Okay, so you have trained your model with some with respect to your data, and when you give a new data to it, obviously accuracy will be according to that. Okay, now suppose we are having a complex problem where we need to perform some predictions. Instead of writing a code, we just need to feed the data into the algorithm. So obviously in machine learning, there are algorithms, there are techniques, and algorithms, there could be regression, there could be classification, there could be clustering, there could be association. So these are certainly algorithms. Okay, for example, if we talk about prediction or regression, if we talk about, so we will apply linear regression. Okay, because if we need to perform some predictions, if we need to perform the classification, we are going to use logistic regression, decision trees, random forest, XGBoost, AdaBoost, gradient boost. There are various other algorithms which are available to perform this task. Okay, so clustering, we are using k-means, k-mode, okay, db-scan. Okay, there are various clustering algorithms also. Okay, so ultimately they are already prepared. These algorithms are already prepared, and these algorithms are prepared on the basis of mathematical foundation. There is some maths, there is definitely a maths behind in development of these algorithms. And what you actually do is you fit your data, which is also in a numeric, in these mathematical equations, and accordingly, when you fit your data, okay, your model got trained, you learn, okay, if I got this data, this is the equation. According, if you fit the data in that equation, you got this particular results. Okay, so your model got trained by fitting this data in those equations, and you got the results. So next time, if you bring some new data and fit that new data into these algorithms, you will get the result according to that, how your model got trained. So as compatible, you get the results. Okay, so here is a block diagram related to the machine learning. See, input past data. Okay, whatever the data you are available with, just input. And where to input in a machine learning algorithm? Okay, train your ML, train your algorithm, train your model. Okay, learn from that particular data, build logical models. Okay, this is how you build your logical models, and now feed your new data into this model which has been already trained, and get the output. That's it. This is the process which we do follow in all your machine learning algorithms. Okay, so what are the features of ML? It uses data to detect various patterns. Okay, what is a pattern, how the data has been correlated or interrelated, or what pattern they are following. From the past data, it obviously learns from the past data and improve automatically. Okay, as much as data you feed continuously to the ML model, obviously it will keep on updating itself. Okay, it is data driven. Obviously data driven, data is everything here. Whatever the data you feed, accordingly your model will get trained, and accordingly your model will answer. Okay, that is a straightforward approach. It's a data driven. Machine learning is similar to the data mining. Obviously, it's machine learning is similar data mining only, and data mining is thing that means if you are having a tremendous amount of data, we need to mine, or we need to process, we need to filter our data and get data which is been in information, just to get a relevant data out of a huge amount of data, raw data. This is the concept which we follow in the data mining. Okay, so machine learning is similar to the data mining. It deals with a huge amount of data, but not that much huge, which has been used in a deep learning. Okay, huge. Okay, I just say some thousands of rows will be available here. Okay, so huge data, but not that much as like a deep learning. So ML algorithms help us in solving business problems, and there could be like regression, classification, forecasting, clustering, association. All these are problem statements which we can solve with the help of a machine learning algorithms. Okay, so we divide ML into various classes or various types. So it could be like supervised machine learning, it can be unsupervised machine learning, it can be semi-supervised machine learning, it can be reinforced learning also. So these are the four categories of machine learning. Basically, we focus on two. One is a supervised, another is a unsupervised machine learning. Okay, these are two our concerning parts. Okay, so if we talk about this diagram, okay, flow chart of the machine learning. So in case of supervised learning, we are having prediction, we can have a classification. So for example, we do a project on house price prediction, medical imaging, or something like that. So this comes under supervised learning. Unsupervised learning, customer segmentation, market basket problem. This is unsupervised learning. I will let you know the definitions of supervised and unsupervised ahead. In case of semi supervised, that is a text classification. Okay, and lane finding on GPS data. This is semi supervised. Reinforced learning, optimized marketing, driverless cars. Okay, that means much more towards those kind of learning in which we are in a requirement of context information. So this comes under reinforced learning. Okay, so let us check what these are. Supervised learning. See, supervised, for example, you guys are learning under my supervision. I am your teacher. Okay, so if you perform learning under someone, this is called as a supervised learning. There is a supervisor. Okay, so supervised learning is a technique when we train our machine using the labeled data set. Labeled data. That means we already know that what is actually the output. So here the training has been done on the basis of the output. That means labeled data means the data which has some inputs, that means some parameters, some features available in the data, and we used to map that with the output. Okay, that means you are also available with the results. You are already available with the output here. So you are having input, you are already having output. So this kind of data is a labeled data. So features are having the results also. Okay, and we feed this data into our machine learning model to perform either regression, to perform other classification, or I would say a prediction or classification, whatsoever you want to apply. We just do the same here in case of supervised learning. So supervised, that means there is a supervisor, there is a trainer here. So trainer will let you know, okay, if you want to do this, this will happen. If you do this, this will happen. So there is an instructor to you. So this is a case of supervised learning. In case of unsupervised learning, you are not having a labeled data. That means you are not available with the output. What you gonna achieve, you don't have any output. So there is no need of supervision here. For example, if I'm not going to take your ML or deep learning classes, then you guys will be learning from yourself. Okay, either you search on the internet, you follow some video tutorials on the YouTube. There might be any of the person who might be teaching there. Either you look out for some articles, either you look out some books. So you prepare notes from your side, and then you will conclude, okay, if this thing happens, so this would be the outcome. Okay, so in case of unsupervised, there is no supervisor. You yourself, that is called as self learning. Self learning, that comes under those unsupervised learning. So in unsupervised machine learning, the machine is trained using unlabeled data set. We don't have any labeled data, we don't have any output. Okay, and the machine predicts the output without any supervision. Okay, so in unsupervised learning, the models are trained with the data that is neither classified nor labeled. Okay, and here, obviously, as I told, that we need to perform clustering, we need to prepare the clusters. Okay, that means ultimately here, by learning from ourselves, we will decide, okay, this could be the outcome. So here we don't have any kind of classification. Model is not trained with, okay, if this could be the prediction, this could be the classification. Here the problem statements comes with the clustering, as I already mentioned. Customer segmentation, clustering, because we don't know, there's no labeling of the data. Okay, so customer segmentation, this project we have already done. Okay, this comes under market basket problem. No, the customer segmentation means market basket problem. What does means? Customer, that means whether the customer will retain, okay, to our service or not. Okay, we need to check out, customer has purchased for this month, and now in January purchase, February purchase, March purchase. Okay, so I need to check out what will be the customer behavior next time related to the purchasing. Okay, so I need to perform the, I need to use k means or this kind of approach to perform the segmentation. Market basket analysis, for example, if a customer goes to a shopping mall or any big basket or Reliance Fresh or whatsoever, if a customer purchases milk, so what is the chances that customer also purchase the bread? What is the chances that customer also purchase the curd whatsoever? So to find the association link between, so this is market basket, link between, okay, these, if this item is purchased, what is the chances that the customer will purchase this thing also, this thing also? So this is market. See, here we don't know, so we are just learning by the behavior of the customer. So customer segmentation and market basket comes under this category. The next thing is your semi-supervised. Semi-supervised machine learning lies between supervised and unsupervised. Okay, so here it represents intermediate ground between supervised, that is we are having a labeled training data, and unsupervised, that is no labeled training data or algorithms. Okay, and it uses the combination of both of them, labeled also and unlabeled also. So here we are having example related to the text classification. Okay, so that can be like labeled also, and it can not be unlabeled also. Text classification, we have performed sentiment analysis also. So that will be the case of semi supervised learning. Okay, so labeling and labeling, okay, that means we are having a data set like, okay, labeled data we are applying, but we are applying unsupervised learning over it. Okay, so it's a combination of both of them, semi supervised. The last one is your reinforced learning. See, reinforced learning works on feedback based process. Okay, they are having agents, AI agents. What does this AI agents mean? For example, you guys work in your organization and there might be CCTV cameras installed. Okay, and they are continuously monitoring your activity, that what you guys do in your office. Okay, continuously there is an eye on you people. Okay, so this sensors, they are called as AI agents. They capture the information, okay, and feed it to your system, and then your system or your your program or a code, they learn from it. Okay, I capture your information and feed it to the system. For example, Alexa. Okay, what is Alexa? Alexa has a reasoning technique. Okay, for example, in your mobile also there is OK Google. Okay, so what does it do? What does it do? That it's keep silent and keep on monitoring your activity, what you are doing on your mobile phone. Yeah, anyone having doubt, please let me know. Does reinforce mainly work? You can unmute yourself, Shweta, also.
No, sir. It's mainly on like real time data, is it? I
Yeah,
mean,
real time data.
then
Yeah, real
okay,
time.
okay.
That is why I told, that is your AI agents or the your CCTV camera. They are continuously monitoring you, and Alexa continuously monitoring. Okay, Google continuously monitoring. Okay, and what happens is, during their continuous monitoring, they are capturing your data, and next time you will not be knowing, here, how I'm getting this kind of recommendations. I haven't, but these systems are smart enough or intelligent enough. They perform reasoning over your data. Okay, so these devices, smartphones, they are really dangerous. Okay, they are really dangerous. Your all kind of data has been sent somewhere. they are stored. Okay, and accordingly you are getting all these companies, all these apps, they always ask your data. Okay, so data is now, it's like a gem. Okay, so this comes under a case of reinforced learning. Okay, so there are AI agents, basically the sensors or CCTVs or whatsoever you can say, and they collect our information and you know perform the action accordingly. So these are certainly the types of machine learning algorithms. But what are the limitations? Let's come back now, come to the limitations. We have already done a lot of projects on the machine learning, and you know how the machine learning performs. Okay, and what problem statement we do take. So these are certainly some problem statements which we perform over with the help of a machine learning: house price prediction, medical imaging, customer segmentation, text classification, driverless cars, that is a reinforced learning. Driverless cars, obviously, there are sensors and stores and capture all the information, and this is how without a driver a car is moving. Okay, so it's a concept of reinforced learning. Okay, so we have already done a lot of projects. So what could be the limitations of ML? See, the limitations of machine learning models particularly depend upon the model and the problem being solved and the data set used for the training the model. Okay, so if you talk about your machine learning models, there could be limitations related to the accuracy, the type of problem they solved, and the quality of data set used. And we are having limitations of all these things. Okay, accuracy also. Okay, it doesn't matter that if you are getting, we have seen that, sir, accuracy, we have achieved accuracy, more accuracy in machine learning also, 98%, 99% accuracy. But what we later on say to them, okay, your model is overfitted, sir, because it's not possible, sir. In real world it is absolutely not possible that your model will give an accuracy of 98 or 99%, because unless and until if you feed any of certainly one of the data, definitely it will gonna fail. Okay, so we never say accuracy of a model is 99. That's a case of overfitting. Okay, so we are limited with their accuracy and the types of problem they can solve. They are restricted the kind of problems which they can solve, and the quality of the data also, which is used for the training purposes in machine learning. Okay, so if we just focus one by one, what are the limitations supervised learning? So supervised learning, we already know about that. Here we use the labeled data. So the supervised learning, but all of have the limitations. Is one of the biggest limitation of this algorithm is we can only learn so much from the data that is being provided. Only we can learn whatever the data you feed in the machine. Accordingly your model will got trained. That's it. The point is very much clear. If you want to have some other learning, so kindly update your data, feed your data again to your model and make it to learn again. Okay, so this is what you need to do. If your data is labeled correctly, then only you will get the correct results. If you are not labeling your data correctly, then obviously you are not getting the correct results. So you should have your data relevant, consistent, and correct. Okay, it should be valid data to feed into the machine learning model using supervised learning. If we talk about the limitations of unsupervised learning, they do not provided with the set of known inputs and the output, and they must learn from the data by itself. Okay, this is what basically happen right now. Okay, in engineering, in my engineering also, and you guys, if you are been a part of it. So we right now also we do learn from the Google is the teacher, right? Google is the biggest teacher. Whatever we don't know, okay, just type on the Google and get the result. Okay, now who will let you know the authenticity? Who will claim the authenticity that this the answer given by the Google is correct or not? Who will authenticate that particular answer? No one. There is no one available
Mm.
to authenticate. Okay, so this is self learning. If you see, internet is an ocean. Internet is an ocean, and if you search anything, you will definitely get an answer. Definitely get an answer, but there is no authenticity of those. There are many resources available on the internet, and students keep on learning. Okay, they from this place, on this place, and that place, and it will. But they are directionless. They are directionless. Okay, someone has read this thing, someone has read this thing, and they are starting working on that. So the main limitation of unsupervised learning is that it is more difficult for the algorithm to learn from the data. Okay, what the exact data should be, I don't know. What should be the exact answer? I don't know. Okay, I got many answers from many other resources, but what should be the appropriate one? I don't know. But still, I'm learning from it. Any suggestion from your side? Anyone want to say something?
So
Yes,
what you're
Shweta.
saying is right, actually. There is no, I mean, they're very
Yeah.
much limited, actually.
Yeah, it's like an ocean. Many resources are
Yeah,
available on the internet, but no one knows what is the
yeah.
authenticity.
Authenticity of it,
Yeah.
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 Okay, so this is a drawback of your unsupervised learning. Then next comes the limitations related to semi-supervised. That is, the quality of the result depends upon the quality of training data. Because semi-supervised, it will cover both the limitations. It will cover the limitations of your supervised also, and it will cover the limitations of your unsupervised also. So semi-supervised is having it's a combination of limitations of both. Okay, so the quality we don't know of the training data. If your data is properly labeled, then it will give you good results. Not properly labeled, obviously it will have an issue. Okay, accuracy has been obviously accuracy has been issue with case of the supervised learning also. Here also the accuracy has been issue. Okay, and obviously the learning of your and as I told that in case of unsupervised also, there's a limitation that the more difficult for the algorithm to learn. So here also in semi supervised, it is more difficult to use semi supervised algorithm than supervised learning. Okay, so learning here is again an issue. The limitations of reinforced learning are that allows the agents to learn how to achieve a goal or to satisfy a condition by interacting with the environment. Obviously, as I told that there are cctvs or sensors, they capture the information of you, and accordingly there is a reasoning algorithm applied over that particular data, and they learn from that. Okay, so it allows the agent to learn from your by interacting with the environment. Now, understanding environment is also a challenging task. It's not like that ki everything is going to be happen wrong, everything is going to be happen correct. So understanding environment is also a challenging task. Okay, you may have an issue. For example, during corona times, it happens that we in university or in the college, they are taking exams, and they are taking online exams. And what happened is they installed some software, for example AI proctor or something like that. If the student is blinking eyes, or if they're just changing the position also, they are what they are doing. Okay, you are doing cheating, you are out of the exam. But the student said, no, I am not doing any cheating. But that camera is capturing, and accordingly it has been trained that if you are doing any kind of wrong activity, you will be out of the exam. So most of the students got out of the exam by that. Then they report to the teacher, no, I was not doing anything. So just blinking your eyes and just changing the positions, and obviously we are humans, so we should be doing. So environment, understanding environment is also a challenging task. So reinforced learning got failed. Understanding environment is interacting with the environment, whether you are doing right or wrong or whatsoever. This learning is a challenging part. So this is a limitation of reinforced learning. Okay, so there could be many limitations related to difficult to appropriate learning algorithm, difficult to find a good learning rate. Okay, what at what rate my learning should have to be. They could be slow learners. Okay, and where the learning can be susceptible, where the learned knowledge is forgotten and no longer needed. For example, I learned machine learning or deep learning so years back, and I'm using the same algorithm here. No, this has not been possible, because every time there is a new challenge, a new problem statement come. Okay, so it is sensitive to the change environment. If your environment change, obviously your reinforced learning should also be changed according to the environment. And we know that environment or the system is dynamic in nature. It's not static. Every time everything is being keep on changing, so behavior, you need to change the behavior. Okay, so these are all the challenges related to the reinforced learning. So if we just sum up, what are the limitations of machine learning models? So machine learning models, okay, anything you want to say?
Yes, sir.
Yeah, yes,
Sir,
Rima.
understanding customer behavior can also be a part of reinforcement learning.
See, understanding customer behavior. Yeah, we can say that. But the point is, if there are AI agents installed, already there are agents installed, and they are capturing the activity of the customer. Okay, and
Yeah.
then they are feeding into the system. Then that kind of problem can also be like a reinforced learning. Okay, that means here,
Yeah.
if you are not available with the data has been captured by the AI agents. If they are working, okay, and they are performing the task, then it will be a reinforced learning.
Hmm.
That means you are eliminated. You are eliminated, and
Yeah.
machine itself is doing all the task in case of reinforced. So what is a driverless car? There is no driver, na? Okay,
Yeah.
so obviously, so the person is not been there in case of reinforced learning. Agents are there. Okay, and they are capturing everything. So if the customer behavior is captured by that all sensors and everything, so obviously, yes.
Okay, sir.
Okay, so
So does reinforcement learning actually have a lot of memory issue, because it seems a bit heavy as an application. I mean, if you consider a driverless car, you literally need to figure out what is moving and what is not, and then I mean, is it very heavy on the memory, or is it? I don't know. I'm just asking.
yes, obviously, memory is an issue for that, because it is susceptible to the environment. As I already mentioned, that environment is not always static in nature. When you are going to implement a driverless car, every time it should have to be learned according to the situation. Situation may come any kind of. Okay, we also drive our vehicle, and we know that sometimes we are good, sometimes we are bad, and sometimes if there is no our mistake also, for someone else's mistake we got hurt.
Yeah,
Okay, so here it's like a dynamic thing. Okay, so memory and everything, obviously this is a machine. It need to take care of each and everything. It should keep into memory, and every time it should need to apply the algorithm technique over it. Okay, so this is
yeah.
quite challenging. This is quite challenging.
Okay.
Okay, so that is why this is one of the limitation. So if I just sum up the limitations related to machine learning models, they are opaque. Actually, they are not open to you. You directly apply those algorithms, okay, and you fit your data into it. But right now, it's no one did explain you completely. Okay, this is how logistic regression worked upon. This is how I got the equation of logistic regression. This is how you fit your data into it, isn't it, Shweta?
Yes, sir. Yes, sir.
Okay, so the point is, as I did ask the question to Shweta, because she knows about machine learning. She told that, sir, I'm already up with this knowledge. So the point is, they are opaque in nature. Machine learning models are often unstable. They can produce different results when they're trained on different set of data. Okay, so if you're training the model with this data, okay, this is the result. If you train this model with this data, this is the result. Now you will say, you will get confused. I have trained my model with this data, same model, this data. This is the result coming, and now I trained this one. This result is coming. Whether I'm doing right or not. So that's a confusion, basically. That's a confusion. They are often biased. Obviously, when someone will give you a confusion, obviously you will bias. Now, obviously, sometimes it may happen that it may give you inaccurate results also. Okay, and if your model is overfitted or underfitted whatsoever, there is an issue. You are getting mismatched results, wrong results you are getting. So this is also one of your drawback for the machine learning models. Okay, it is difficult to customize, meaning it can be hard to change their parameters. Okay, to adapt with a new data set. No, we can't do that. If we need to train model to starting itself, you need to train. Okay, we can't change. Okay, we train our model with 10 parameters. Now with the same state of the model, I need to train with two more parameters to it. No, it is difficult. So you can't customize it, and this is also one of the challenge. Now, machine learning models, they are often expensive to train. If obviously the amount of the data and the training, and that they could be quite expensive, take lot of time also to train your model. Okay, to build a model accurate, to get the accurate results. They could be vulnerable to the learning with noise. Obviously, if you are feeding incorrect data, corrupted data, if you're feeding corrupted data is called as a noise, basically. So obviously it will give an issue to you. Okay, so vulnerable to accurate predictions, sensitive to the order in which the data is presented. Okay, the, as the way you presented data, as the way you fit the data into ML model, it is directly proportional to it only. Okay, so you will produce, it will get the result, and it will produce the result according to that only. If you rearrange the data, obviously, that is why I just every time told train test is split. We used to have no train test is split, so that it is automatic auto splitting of the data. But if you split the data according to your conveniences, it may have a chance that you will get different kind of output. Okay, so according to the arrangement of the data, they're often sensitive to the scale of the data, means they can produce different results if the data is aggregated or disaggregated. Depends how the arrangement of the data has been there. As I already told, that train test split, that is auto splitting or manual splitting. How you do that, how you scale your data. Okay, for example, you change the ratio like this 80/20, then now you change your ratio like 70/30, 70% for the training, 30% for the testing. Okay, again, if you scale your data accordingly, obviously the results may get changed for the machine learning model. Okay, sensitive to data distribution, meaning they can produce different results if the data stored in a different way. Okay, distribution of the data. Then next, they are often sensitive to the selection of the training data. I've already told about this. Okay, that means it is biased. If the training is not represented or the data set, then it will use to make the predictions accordingly. Okay, so your ML model is sensitive to all this stuff. Okay, so here I found that most of the things in case of machine learning, because machine learning itself known for data driven. Whatever you are giving the data, how you are giving the data, your model is going to perform like that only. And obviously it's a mathematical equation which you have derived with the name of different models. You are putting them and getting the results, not any other thing is been available here in case of machine learning. Okay, so these are the limitations. Do you have any doubts? Any doubt? So the next revolution came with a big data, not only limited data, because now most of the companies, whether you take on any of the social media website or any of the website, whether it is Amazon or Flipkart or any of the website you take, a huge amount of data has been available. Okay, and day by day data has been increasing only. Okay, so I need to make the predictions with this data on the basis of experience. Okay, I need to learn. I want to make a system which will learn by the experience and perform the predictions on the basis of that. Okay, so I need to improve the capability of the system, and this can't be done with the help, only help with the machine learning, because machine learning is having limitations I've already discussed. Okay, so because of this particular issue, they are having these limitations, and they will produce inaccurate results for my calculations. So I need to switch out to another technology that is called as a deep learning. Okay, so do you guys have any doubt, or shall I proceed with the deep learning?
It's clear, sir.
It's clear. Okay.
No, sir, no doubt.
Okay, so let, let us move ahead to the deep learning. All right, so introduction to the deep learning. So in my first part, I told you that what are the limitation, what made you to come to the deep learning. So you now got understanding why we are here and why we are doing this course for the deep learning. So deep learning is based upon conventional artificial neural networks. Okay, that is a subset of a machine learning. So deep learning is not came apart from the machine learning. It is a subset of machine learning only. Okay, and here in case of deep learning, we are using it is based upon conventional artificial neural network, that I will explain you what is this artificial neural network is. See, artificial neural network is made up of neurons. See, neuron, or I would say perceptron, that means the units which have a capability to perform the computations. Okay, computation capabilities. Okay, so they are called as a neurons. So artificial neural network is a connection of these neurons, these units. Okay, these cells, it's a combination ANN and artificial. See why I'm calling it as an artificial, because if we talk about my brain also, my brain also comprises of the neurons, and they are interconnected. So whatever the learning which I am been doing, they are because of these neurons only. That is what I'm doing. So similar to our biological brain, similar to our brain, artificial neural network has been created. Okay, and their if we talk about their architecture, it is layered in nature, and every node or every point or every neuron or every perceptron is been connected accordingly, and they are called as a processing elements basically, which take the input, okay, and perform some computation and give the output. So here we are not talking about like a machine learning model that we are having, like some mathematical kind of thing, or in which we fit the data. Here also will fit the data in case of ANN, in case of deep learning here also will fit the data. But the point is we are having a layered architecture. There are certain layers available. We haven't talked about any kind of layer in machine learning, but here there are layers, and in layers there are some processing units which are called as neuron. Okay, and these neurons are similar to our brain, and they are connected. These are the connection points, and they are connected with each other to perform the processing. Okay, because if I need to learn something, there is a processing. Because I capture some information, some data I capture, I need to learn accordingly, okay, what exactly this is. So I will feed my data to this network which is having neurons. Neurons are the processing elements. Okay, they understand, okay, what we need to do. Okay, so if we talk about the architecture here, in case of ANN, simple artificial neural network, we are having an input layer. Okay, we are having an input layer.
Is the screen stuck?
I think some network issue or
Yeah, yeah, correct.
okay.
All right, so yeah, I was discussing about the layered architecture of the artificial neural network. So here I am available with an input layer. Input layer, that is the initial data we give to this layer. Okay, that is input. We give the input via input layer. Then I am available with the hidden layers. Okay, so hidden layers are next to the input layer, and it is in between the input and the output layer where I perform all kind of computations. Okay, so whatever the computation which you are doing, whatever the calculations which you are doing, that is been done on the hidden layers. So input layer is just to give the input, and the output layer is to produce the output. And in between these two layers we are available with your computational layers, or computational layers I would say hidden layers, and in the next term I will say them as a dense layers. So in case of artificial neural network, initially if we talk about ANN, artificial neural network, we are just having one input layer, one output layer, and one hidden layers. Okay, so it may happen, because in case of deep learning there could be several hidden layers in between input layer and output layer. So right now whatever the algorithms which we are having in case of deep learning, they are having multiple hidden layers in between input layer and output layer. That means they are now the advanced layered architecture of your artificial neural network. Okay, so here I have shown you the architecture of ANN also, ANN and deep learning. So here you can see that this is an input layer. You can see there are three perceptrons or the three neurons available here. So this is an your input layer. Then next to the input layer, I am available with the four neurons or the four perceptrons. These are the hidden layers. And the next one is the output layer, which you are seeing that there are two neurons. Okay, so this comes under your output layer. Okay, this is your conventional neural network, or I would say artificial neural network, which comprises of only one hidden layer. Okay, now if we talk about deep learning neural networks, so the case is same. Here you can see that there is one input layer where x1, x2, x3, here also an x1, x2, x3. These are the inputs which are given to the input layer. So x1, x2, x3, these are the inputs. Okay, w1, b1, w2, b2, w3, b3, these are the weights and the bias. I will explain you ahead what are the base weights and the bias. Okay, so these three are the hidden layers. Okay, these three are the hidden layers here. That means I am having more than one hidden layer available, and obviously one output layer to produce the outputs here. So this is the difference between ANN, that is artificial neural network, and deep learning neural network. Only the difference is I'm available with many hidden layers in case of deep learning. Okay, so this is what just a general thought related to it. Okay, and if I would say that what basically do you think a neuron is? How you will define a neuron? How you will define a neuron? Any idea what does a neuron means? What is the meaning of a neuron? Anything? Because here this is again, I just say it's a processing unit in deep learning, and whatever computation you are going to do, that has been going to do on the neuron itself. Okay, so what's according to you a neuron? How you define a neuron? Someone say.
Maybe something which processes the information and passes it around to the next one.
Okay, yes, you're correct. See, neuron, to be very basic, these are the interconnected nodes. Okay, interconnected nodes in your architecture, which I have already shown here, and it is having a same task as our human brain used to do. Okay, so if I would say that uh, I will show you ahead what our brain also, what is the architecture of our brain. Before that, let's have a discussion that the deep learning, if I just say, it has been divided into two types, that is convolution and recurrent neural network. Convolution neural networks and the recurrent neural network. Ahead I will explain you each and everything. What is weight, what will be what is weight, what is bias, what is what this means, what is an activation function. We will all discuss ahead in our this lecture series. Okay, so that is why first I asked you neurons. So neurons are, these are the computation elements. Okay, these are the nodes which are interconnected, and obviously they are used to transmit your information or data from one layer to the another layer. Okay, so if someone asks what is deep learning and what is the neurons, you should be asked, and it resembles with your human brain neuron. Okay, so deep learning is divided into two categories. One is CNN, convolution neural network. I hope you have heard a lot of times this name CNN, and whenever you do any kind of project related to the computer vision, CNN comes into picture. Okay, so CNN, it's mainly for the images, while recurrent neural network are for the sequence data such as text or the time series. Okay, so we use recurrent neural networks for text and time series kind of problems. However, if you want to deal with the images and the videos, and but CNN is not restricted or limited to it. We can apply CNN for other tasks also. However, mainly the architecture of CNN has been developed for this purpose only, related to the images, problem statements related to the images. Okay, so if I talk about the history of deep learning in 1989, Yan Lee, okay, they proposed a CNN model that is called as Lenet. Okay, they in 1989 itself they have proposed a model, and that is been based to recognize handwritten digits. Okay, whatever there is which you have written, it is this model learnet has been used for that purposes. In 2010, Professor Fei Fei Lee, or I would say Lee of Stanford University, they created ImageNet. Now this is a breakthrough. ImageNet, and ImageNet comprise, it's a huge database of images. So as I told, that the limitation of machine learning, we can't work with the huge amount of data. Here we are available with 14 million images in ImageNet. So in most of our algorithms also we use ImageNet. Okay, and ImageNet comprises of 14 million images daily, day to day images, and it divided into 20,000 categories. So already a database of images all available, such as cats, dog, car, table, chair, etc., etc., all available in ImageNet. Okay, and we use this ImageNet in an annual challenge on image classification, that is called as ImageNet Large Scale Visual Recognition Challenge. There was a challenge offered in the year 2010. Okay, so ImageNet challenges, you only use 1000 categories for that, and this competition ran for 7 years. This competition ran for 7 years. Okay, and then later on it moved to the Kaggle after 2017. Okay, it moved to the Kaggle in 2017. Okay, so this was an exceptional breakthrough for this your deep learning related to the images. Okay, now the next thing is, uh, this work didn't stop here. Okay, this work didn't stop here. बेटा आवाज नहीं करना है ना, ठीक है। हाँ रुक जा, तेरे को लगा देता हूँ। आवाज नहीं करेगा ना, हाँ रुक जा, मैं देख तेरे को लगा रहा हूँ ना, तो बस बिल्कुल आवाज नहीं करना। रुक जा, हाँ आवाज कम करूंगा, रुक जा, रुक जा। हाँ हाँ, तू चला चला ले, चला ले। आवाज नहीं करना बेटा, ये क्यों लगा रहा है, ये क्यों कर रहा, ये क्यों कर रहा है, ये आवाज ही तो है बेटा, आवाज नहीं करनी, आवाज नहीं करना बेटा, आवाज बंद रहने दे। ये इसको बंद करके, आवाज बंद करके दे दो। मेरे को बस, मेरे को 5 मिनट और पढ़ाना बस। तो फिर इसको अब क्या करूँ मैं, अगर रो रहा, दिखा दो 5 मिनट, 5 मिनट और दिखा दो, है ना, बस मैं क्लास खत्म करूँ, उसके बाद मारना जो भी करना है, बस जो करना है बस। 5 मिनट और बस, ले देख ले देख ले, चुपचाप देख, चुपचाप देख, 5 मिनट और दिखा दो, मेरी क्लास चल रही, 5 मिनट और दिखा दो। फिर बेटा रो मत, है ना, कुछ मत कर, है ना, बस 5 मिनट और देखो, जो करना करो, उसको बाहर घुमा लो, कुछ भी देखो। Okay, so yeah, just a technical issue. Okay, so again, this been a breakthrough, and if I talk about other researchers, they developed AlexNet in 2012. Alex and its team, they developed AlexNet in 2012, and they give excellent accuracy for the image classification, like 85%. So AlexNet took place first in the contest. Okay, so the if it defined about the accuracy also, previously the accuracy was 74%. Okay, now in case of AlexNet, the accuracy was much more better for the classification, it was like 85%. Okay, so top one accuracy of the image classification, there are some definitions also. The top one accuracy of the image classification tells how well the prediction match with the anticipated result, because here we are having a result. Okay, this image needs to be of a dog, this image needs to be of a cat. Okay, so if your algorithm, if your technique give the prediction correct, okay, that okay, this is the result we got, because if you train our model, if you train our CNN model, and if feed our any of the image into your CNN model, and if you give that, okay, this image is of a cat or this image is a dog, then we say that how much accurate your model is. So they gave accuracy of 85%, that okay, the prediction was absolutely correct related to it. So if we talk about the AlexNet, the depth of the model was essential to original AlexNet publication, and it performed well, although it was a bit expensive in the calculations, and it requires the GPUs. You very well know about the GPUs. In case of Google Colab also, we use the GPUs, that is graphics processing units, GPUs, to perform the computation. The next work come from the another researchers, that is Geoffrey Yan, and Canadian computer scientist, that is Joshua. They are called as the godfathers of AI, basically godfathers of AI, or I would say the godfathers of the deep learning. In 2014, Google came into the picture, and they developed GoogleNet, okay, which is now called as an inception model. Inception model. So we are again the same task they are also doing, the image classification. They are also a collection of images, okay, they are also doing the image classification, they are also doing the image classification things, okay. And the Google in 2014, they published a paper. So whatever you are seeing here, that is related to the LaneNet, or whether you are AlexNet, whether you are the GoogleNet, whatever you are seeing here, they are huge database, they are of the images, and they are an approach or algorithm or a technique to they are having an architecture to perform your classifications, okay. So in 2014, there was a paper called as going deeper with convolutions. On the basis of that only, GoogleNet has been been available, it's came into picture, okay. And later on, it is called as an inception model. Right now also we are having inception model, inception v1, inception v2, inception v3. We are having a version of inception models, and we do use this inception models for our image classification. For example, I did a project on brain tumor classification, breast cancer detection classification. We are using this inception techniques, okay. Similarly, later on, another model called as VGG, they came into the picture with the researchers Karen and Andrew of Oxford. Okay, that is visual geometry group. VGG is called as visual geometry group. Again, this is an algorithm or a technique which has been used for the image classification. They are also having a good classification rate over the images. Okay, so next thing came for the object detection. As we know that, as you also know that, object detection is something a task which is very complex in real world. However, we are available with now so many algorithms for the object detection in case of computer vision. So all these things which you are learning here, they are the cases of computer vision, okay. Here, in which we give our image as an input, train our model accordingly, and we get the predictions or the classifications according to the images which we have input, and there is a proper procedure to perform this task. And these all tasks are being done on the basis of an architecture of the model or the technique which you are using. So we will definitely going to study each and every one architecture, each and every one layer, what are its components, what they are doing here in case of deep learning. In 2019, efficient net also came. Again, top 5 classification accuracy 97.1%. Okay, now you can see that from initially the accuracy was 74%, we moved to the accuracy of 85%, and now we have also moved to the accuracy to 97%. This is how the classification has been done. This is how the accuracy has been improved, okay. So you can see that this is the time chart for the ImageNet. ImageNet is a huge database, and we have used different techniques to perform the classification for the ImageNet, from AlexNet, also from Inception v2, Inception v3, ResNet, and then we are having many algorithms to perform this task with higher accuracy advantages. 2021 till 2021, efficient net L2 we are available with. And for object detection, you very well know, if you have attended my session also, YOLO, you only look once. You did worked upon that for the object detection, okay. So why we are doing all this tasks? The reason is the classical machine learning methods or algorithms, they are not efficient enough. You've already seen that they work with a limited amount of data. But if your data got increased. If you're having tremendous amount of data, you can't use your machine learning techniques, you need to use your deep learning techniques. Okay, so the performance of conventional neural network, ANN, they have only one deep learning, or I would say not deep learning, there is one only dense deep or I would say denser algorithm, denser layer in between that. Okay, so here in case of deep learning we have improved the architecture of it, and we have improved intermediate layers. Many intermediate layers is now been available between input layer and the output layer. So in case of conventional or artificial neural network, it works with one input layer, one output layer, and one hidden layer. But now with the help of your deep learning, you are working with one input layer, one output layer, and multiple hidden layers. And this is the performance chart. Okay, you can see that when your data goes on increasing. Okay, initially machine learning was working better, but when your data was goes on increasing, you can see a threshold point here. This is a threshold. Okay, where there is an intersection of machine learning and the deep learning. So this is the threshold. Okay, so after that, once your data get increased, machine learning accuracy, this is the performance of the accuracy. The accuracy of machine learning is down. However, we can see that the accuracy of neural network is improved, or a performance has been improved. I will not say strictly the accuracy, I will talk about the performance. Performance is based upon the results. Okay, so your results got improved with the help of a neural network when your data has been increased, and much more results you are getting better when you are using the deep learning techniques or the deep learning networks. Okay, so you can see that this is the graph. This is a comparative graph between machine learning neural network and deep learning networks, and everything depends upon the data. This is the main reason, volume of data. As the volume of data increased, this is how you got the performance. Okay, so this is all from my side for the lecture number 1. Okay, let me stop the recording.